What's up guys, this is Josh here from Clever Engineer, and in today's video we are going to be solving Leetcode 876, middle of the linked list. Given the head of a singular linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay, so what this problem is saying is that if they give you a linked list like this, a linked list is basically a data structure that have a pointer to the next node, so it's made out of node that have pointer pointing to the next node, and then a pointer pointing to another next node, right? So they are saying that if they give you the linked list like this, you should return the middle of the linked list. So now 3 is the middle, and then from 3, so now 3 from 3 or 4 5. So if they give you an input like this, you should return the middle like this, right? So how do we go about doing this, right? How do we go about doing this? Of course you will use the brute force approach, but that won't be so efficient. Probably you could take the whole list, count it, put it in an array, and then you decide to return the middle of that array, but that will be long. So there is an easy way to go about this problem, and the easy way to go about this problem is what we are going to discuss in a few seconds in Linkedlist. So firstly, before we do that, I want you to hit that subscribe button and make sure you keep up to date for all our new videos. And if you want to really help us, you could follow our Facebook page at Clever Engineer. So let's go there, let's get this problem on. Yeah, so we having the linked list here as stated in the problem. So the technique we want to apply today is called a fast and slow pointer. So fast and slow pointer is a beautiful technique that allows us to find the middle of a linked list. This technique is basically used if you want to do a merge sort on a linked list. So if you have done a merge sort before on a linked list, then you probably have done this technique before, right? So it's a fast and slow pointer. So how it works, right? So let me just read this here. We have slow, and then we have coming. Get this one. Then we have fast, right? So this is for the slow pointer. I might want to erase that and do it better. So yeah, okay. Alright, so yeah. So we have the fast pointer. This is fast pointer, and then we have the slow pointer. So how it works, right? So at the beginning of our list, if we are given our list, we want to have both pointer pointing to the head of the list, right? And then we want to adjust certain pointers, right, based upon what we want to do. So the fast pointer, usually our fast pointer will move 2 steps if our slow pointer move 1 step. Or we mean that for every time our slow pointer will move, every time S, okay, let me just point S to the beginning. Yeah. So for every time S will move 1 step, fast pointer got to be adjusted 2 steps, and you will see why it's necessary in a short. So let's run the algorithm and see how it works, right? So if okay, actually probably let me start with the slow so you get what I'm saying. So if the slow pointer, which is sitting on the head now, it will move one step, our fast pointer will move 2 steps right here, right? 2 steps right here. 2 steps. So if the slow pointer move 1 step, our fast pointer going to move 2 steps, right? Now if the slow pointer move another 1 step, that is to say that our fast pointer now it will have to move, because it was here, so now it had to move here and it will be here, right? So our fast pointer will currently be pointing to 5, and then our fast pointer the next, right? Because this is a linked list, so you have something like the next. So this is a linked list here. You have something like the next, which is come on, I know what happened here, but okay. So our fast pointer next, this will be pointing to, null, or it will become unbounded here, right? So since we have set the information, and you know that if your fast pointer will move, the next will be pointing to null, you can currently see where your slow pointer is sitting. So where our slow pointer sit now? Now this is what we're looking at. Our slow pointer sit here at 3, right? Our slow pointer is currently at 3, and now this 3 here, watch it, is the middle, is what we are looking for, right? This is the middle, right? So this is the middle of the list, and if our slow pointer is here, this is the middle, and our fast pointer is already here, it means an end, right? It means that we have already found the middle, and we just need to return the middle, which will be the slow pointer. We need to return the middle, right? So it works like this. When fast moves 1 step, slow moves 2 steps. When slow is at the middle, fast will be at the end. I hope you get that. So let's jump back into Leetcode and try to code this up, right? So to code it up, firstly, I want to start with the slow. I will set it to be equal to the head there, and then I will start with fast. Fast 2 will be equal to the head, and then we get let me say fast. Y fast. You will actually, there's a shorthand format for doing this, but I will show you later. So, Y fast is equal to none, and fast dot next doesn't equal none. So we will transverse this list, right? Equal none. What we will do here is we will say we will adjust the slow pointer to move 1 step. That is, this will be equal to slow dot next, and this will be fast, which is equal to fast dot next, right? So now we have just applied our technique. So the next thing we want to do is come here and return slow. So yeah, so that's just it, and this will find you the middle of your linked list. This is a very important problem, and in our next video we're going to see how is this problem very important, and this pattern is very important for you to know. So for now, let's just run the code and then see if it works. Yep, so it passed the test case, and as you can see, yeah, so let's submit and see if our submission is okay. Yeah, so currently waiting for it, wait for it a bit. Okay, so our submission is accepted. The actual time complexity of this is O(n), because you have to go onto all the elements. Now, yeah, for the fast pointer, it had to go, but for the slow pointer, you have a complexity of O, say O log n, yes. And then for the memory space is O of 1, because you're not using any constant memory. So I just hope that help you, and yeah, so I just hope that help you, and don't forget to subscribe and like most of our video. So yeah, so thank you, and I appreciate you, and we'll see you in the next video. If there's anything you are confused about, please, you can hit me or reach out to me in the comment section. If you have any correction, maybe I messed a few things up, or I could have done it better, you can reach out to me too, and I'll be willing to hear from you. Yeah, I'll be willing to hear your praises and hear your critics. So yeah.